I use the word complex, it opens it up, maybe some eyes in there. Now here's a short story leading into what this is all about. I think it's very appropriate to point this out. At one time, I supervised student teachers. Some of you guys may have had a student teacher, a student who was planning to become a teacher, and they're at the university, and they're going through a program to plan to prepare to be a teacher. And one part of their responsibility, some of you guys may go through that one of these days, is that their senior year at the university, we would send them out to local high schools, and they would stay there 6 to 8 weeks with a teacher, and watch the teacher do what the teacher did there, and also did a little teaching on their own for maybe 6 or 8 weeks for practice. And then my responsibility was, I had to leave the university and go out to those schools, and randomly I just had to choose a school where those teachers, student teachers were located. And I sat in the back, and I just sort of had to jot down some notes as to what I saw, and then talk to that student teacher and say, well, I saw you doing this, that looked good, I like that. But I did notice the classroom was not under control a little bit, maybe you need to talk about classroom control, things like that. And then they would listen, I would critique, and so forth and so on. As I was sitting in one classroom, still remember this, in the back, the teacher was teaching, and she asked, this is the purpose of bringing this in right now, she asked the class, this is a middle school, to solve this equation. Watch carefully. Listen carefully. I thought it was cute. Solve that. We and those middle school kids, they had already gone through factoring. They knew how to factor back in middle school. So they were doing this right quickly for the teacher. And I was watching. And they said, oh my goodness, and they split this up like we do here. And they're telling me in no time, this order. If I factor that correctly, guys, are those the zeros, the answers? Well, I was sitting next to a student in the back, close by, and I could see what he was doing. He got the answers, but he wasn't doing that. And then when I discussed this with the teacher after class left, I mentioned the particular student. I said, I noticed, and I called him by name. I said, I noticed in the back there, he got the answers there on that first problem you gave, but he didn't factor. And she said, Ramsey, he does not know how to factor. Or he's having some difficulty with factoring. He could factor some, he had difficulty with factoring, and he was just really did not understand factoring. I can understand that. So he did not factor. And she said, I said, but he still got the answers. So I was curious. So when I went in the next time, sat right next to him again. And they were still talking about solving equations, quadratics like we do. And most of the kids were now using quadratic formulas, now advanced up to quadratic formula. Well, he had difficulty with quadratic formula also. Didn't know how to factor, but I saw him earlier get the answers to this. Anyone tell me if your factoring skills are weak and you were asked to solve this, can anyone tell me how was this kid in middle school? Because I finally asked him, how did he get this?
Completing the square?
No, completion of the square would be worse. He has no clue what completion of the square. I don't think any of them in that middle school knew how to complete the square. That teacher was happy they got quadratic formulas. No, he was doing something so, and it was easy. Because I asked him, I said, how'd you get those answers? Because he didn't know how to factor. Because he wouldn't know what he did. That's a clever, he was clever. I will give him that credit, very clever. And what he did to get those -2 and 3.
Input number, what I want.
Tell me again.
Input number, x value on the
bring it to him. I just love the way kids think. And then he, on the side there, he was thinking, what times what will give me -6? And he started listing the numbers that would give him -6 as factors. And he came up with, for -6 here, this, or this, or this, or this. That's right, guys? I think those are the only factors. He could list those. And guess what he was doing after he listed them? And she asked him to solve to get the answers. I asked him, I said, what are you doing next? It's not like, you're clever. He said, I'm taking each one of these, and it takes a little time though. He said, for example, if I start here, I'll take 2 back and put it in what she gave me. Plug it in, if I get a 0, I'll accept it. Then I'll try -3, plug it in, do the math. If I get the 0 that she wants, I'm gonna accept it. And of course, when he finally tried these 2, he got the 0, it satisfied the equation she gave, and therefore he got those. I said, wow, so he smiled, and I smiled. We were all smiling. Wow. I know, just go to the end, the constant term, list the factors, plug them in, a little lengthy, but he got the answers. He didn't do it like we do. He didn't do this business at all. I said, wow, I'm so impressed, that's so nice. And then since I was there, I said, I want you to try this one for me. I like what you're doing there. I like your little process there you're doing here on this one. And, yeah, here we go. I asked him to solve this quadratic. I don't want to mess it up. I think it's got down correctly. I think so. Now, you know the first thing he did. In his little method, he went to the end. His eye was focused on the constant. And he got, for the factors, he listed all the factors of, in this case, -5. Like he did here. And 1, -5, -1, +5, those were the only factors. And he plugged those in, and I think he discovered nothing worked. He was very patient. He plugged in 1, he plugged in -5, did the business there. He started getting a little frustrated with this little system. He thought he had a little system. Yeah, it worked nice up here. Didn't work here. In fact, if we do factor, let me go and see what the answers are. If I factor, I'm going to try 3x and 2x. Go through pretty good factoring here. I think it's a -5 that goes here, if I'm right. +1 there. Let me step back and look at it. I think that's true. Is it? Is it factored correctly? Yes or no? Therefore, this says x is a -1/3. This is the way we do it. And x is 5/2. Those are the 2 answers. His little system's not going to give him that. What's the difference in the one that's the first day I attended class, she was just giving basic ones, basic quadratics, and his little system worked. And all of a sudden, the next time I came in, she was talking, and I gave him this one to work with, and his little system did not work. What's the difference? What made the difference there that this kid did not recognize until we started discussing? Yes?
Coefficient of x.
Thank you. The leading coefficient, the one day I attended class, the leading coefficient, the teacher kept this to be a 1. This will work. If you're patient, this will work.
If you have patience.
This one, coefficient, not 1. This will not work. Oh, he got frustrated. He got frustrated. I think he told me to go back to the university where I should be. He got frustrated. Yeah. Didn't work. Now, Miriam has been asking me. Here we go. And now from from that little story comes what we need for the handout. How am I gonna look at an equation and determine the zeros, the answers for a polynomial function to work with? Now, guys, let me check and see if I brought something in first. I did. Now, the handout, since I gave the handout to you, I know there's a lot there, and I'm gonna tell you which parts I'm looking at here shortly. Let me just jot down this on the one side of your handout. It's P of X is equal to, on the side here, this. 2x cubed plus 11x squared subtract 7x subtract 6. Now, if you walk into just a typical middle school, anywhere, not just California, anywhere, I don't think they're talking about these in a middle school. Unless, who knows, I don't know, some schools maybe have accelerated programs, and they might do that. Guys, this one says I'm supposed to find 3 zeros. That's my degree. Gotta find 3. Now, are you gonna be like the kid back in the middle school? Or are you gonna say, Professor, if I'm looking for the answers, I'm gonna go directly to the end here and list the factors of -6 like he did. Right here. I'll list those again. And I'm patient, Professor. I'll take each one back to the function you gave me, and I'm very patient. I'll replace X by those numbers and hope they work out. It'll take me forever, but I'm patient. But at the same time, I gotta keep in mind, as I told the kid in middle school, did I throw a coefficient out front that's other than a 1? Oh. So what I have to do is modify that kid's procedure he was doing. And we just modified what he was doing there. Guys, I'm gonna take those numbers there, -1, -6, so forth and so on. I'm gonna place them like this. Here goes, underneath here. Let me do it in red. -1, 6, +1, -6. Just missing them in horizontally. And there they are. That's what he was doing. But since I placed the coefficient out front of a 2, I gotta modify it. That's what you're gonna do with it. I'm gonna now place underneath those factors the factors of that leading coefficient, which threw him off. And guys, factors of what? 2 or what? 1 and 2, -1, -2. Now we'll give a name to all this here shortly. I'll give a name to it on your handout, so forth and so on. So guys, we'll take what the kid did, list all the factors of my constant term on the end, done. And then underneath it, list all the factors of that leading coefficient, which could have an effect on the answers. In fact, you saw that middle school problem, it did have an effect. And then, what am I gonna do? We have to be very patient and look at each one of these red ones on top over here. We've gotta find all the different combinations. -1/1, it's a possibility, might be one of the answers of the 3 I'm searching for. Michael? It could be -1/2. Could be one of the 3 answers I'm searching for. Or we're going to be searching here. -1 over -1, +1, maybe one of the answers. -1 over -1/2, as a ratio, +1/2, maybe one of the 3 answers I'm looking for. As if that's not hard enough, 6/1 might be an answer. 6/2 might be one of the 3 answers. 6/-1. You gotta do that to each one of those numbers. And list all the possibilities, and then list the possibilities, and then test the possibilities. Now, I'm not gonna have time today to get through all the little techniques to shorten this down somewhat for you, no. But let me just give you the essence of what's going on here. So guys, you gotta start choosing now. Every time I teach this for the first time, when I throw it out there, I always say, does someone have a favorite number of all those possibilities coming out? Now, let me start listing some of the possibilities. I'm not gonna list all of them. You would have to list, these are possible answers. I gotta make sure I get time for your extra credit also. Okay. Possibilities, -1/1. Let's list some of them. A -1/2. -1/-1. -1/-2. Then you move over to the 6. 6/1. 6/2. All the different ratios, fractions. That's why I'm forming your ratio. 6/-1, 6/-2. One nice thing, if there's a nice thing at all about that, these next two would just repeat what I have already. Don't have to worry about those there. Then you jump down here and say, oh no, professor, here goes my, it's got 4 possibilities. 2/1, I'll put it out here. 2/2, that's that one getting lost. 2/-1, and 2/-2. Now that takes care of that. -3, -3/1. You say, professor, we're gonna be here rest of the summer. -3/2, -3/-1, -3/-2. That will take care of that one, and if you take a close look, these two will just repeat what I've already done. Is that true? Now, in fact, let me count. In fact, I think some of the answers may repeat themselves in the group. You know, 6 I do. I got 4, 8, 12, right now 16 possibilities. All right? Miriam, here goes. At least for today. And I'll give you some shortcuts. Does anyone have, of those 16 possibilities staring at you, one that you think, professor, might be one of the 3 zeros that I'm looking for? And I see a hand going up. What number is it? Wow. Now, why he chose that, I don't know. Maybe I should ask him, because we've got 16 possibilities. And he says, professor, for some reason, I like this number. Was there a particular reason?
Yeah, well, I think we should just go along with it.
He says, just go along. Just go along with it, professor. I just randomly chose that. I just sort of like the way -1/2 looks, and it looked like a nice number, well behaved. So I'll just accept it. Okay. Now what you're supposed to do, I will do this for you today. You're supposed to, as a kid in middle school, you're supposed to be patient, take his choice, -1/2, and replace x by -1/2 here, which means cubit. -1/2 here, -1/2 here, and then finish up with a -6, just regular, plug it in the number, substitute, and hope you get a 0. Now, that's gonna take a little time, because that -1/2 is an awkward fraction to begin with, not too awkward, but you gotta plug it in, right? So I'm going to introduce this, and it takes a shortcut. Save you some time on direct substitution can take some time. To save you a little time, your textbook and all textbooks, they've introduced something called this. Synthetic substitution. Synthetic substitution. All these mathematicians, they come up with all kinds of plans. What they want to do, they don't directly put that -1/2 in there. You can if you have the time. No, do it like this. They say, first, block off on the side here the number you're testing. And he gave me -1/2. That's good. Then go to your function that you're dealing with. Here's my function. I'm trying to find the 3 zeros for it. Jot down the coefficients of the constant, all the numbers associated with it. Like this. We got 2, 11, just the numbers, -7, -6. function itself, and then he gave me the test number. So just block it off on the side, I will not do it by direct substitution. Draw a line. Here goes. In this process called synthetic, not direct substitution, you always start with placing a 0 underneath the first number, always. Then you add those numbers up in that column, first column. 2 plus 0, of course, is 2. Get 2 here. Now I need a number to place underneath this one. So I go all the way across. You find that number, you multiply these two together. The outside number times the number you just got. Multiply these two together to see what comes up next. And guys, -1/2 times 2 is what? Is that -1? So -1 goes here. And you add up those numbers in that second column. 11 subtract 1 gives you what? 10. Mr. Professor, what goes underneath the -7? Try to finish it up. They go back, multiply these two together. The outside number again. So 1/2 of 10 gives me a 5. That's my next number. And that gives me a what?
-5.
Oh, -5. -5. That's going to give me a -12 altogether. A negative times a negative gives me a positive. And 1/2 of 12 is what? +6 altogether. That goes here. Now, with all that, will I eventually end up with a 0? Which says it worked. Oh, Professor, it worked. The 1/2 that he gave me of those 16 possibilities works. That's one of the 3 answers, right here. Right now, I have, with his help, hey, we have 2 missing. Now, let me erase. And to do this today, let me erase, get some room here. Now, I just erased all my possibilities. If, this is up to you. You said, Professor, can I test another one of those 16 possibilities? He gave you -1/2. Does anyone have a favorite of the remaining 15?
1.
Oh, I guess a 1? Okay. What you could do now is stack this up and say, I'm gonna test again, another number, Professor, but you don't have to go back to the beginning. That's one nice thing. After you find one to work, which I did, you get to stack it up like this, and my students say, Professor, test 1. And use that same process you were showing us just on those numbers, remaining numbers. Let's see if I get a 0 on the end again. If I do, one works. Let's try it. Always start with a 0 in the synthetic here. Add those up, of course, and we end up with a 2. The next number coming up underneath the 10, product is 2, so the 2 goes there. Of course, we end up with a 12. 1 times 12, my next number is a positive 12. That's cute. And you finally end up with a 0. Isn't that cute? Oh, by the way, was one a possibility of those original 16?
Yeah. I think those 3, like, out of those all.
Yeah. Now, does anyone have, we have one more to find. We'll put that 1 there, because we have another 0. There's one more. I see a hand going up. What is it?
-6.
-6? -6.
Yeah.
I hear -6. Okay, we'll try it. Now, say, Professor, -6, test it. You can stack this up. Thank goodness, it's not gonna be too demanding on us, because we're down to this point in my synthetic. Okay, 0 here. Get a 2. No problem. And then the product, -6 times 2 gives me a -12. How cute. I get 0 again. Do I now have all 3? I was expecting 3, I got 3, with the help of my students. And there you are. Now that middle school kid back years ago that I saw doing it, oh my goodness, he'd still be working on this problem. He would still be working on this problem. Now, sometimes you know how math is. Sometimes you'll be working with math with a friend of yours, and all of a sudden your friend sees something that you don't see. And says, oh, I guess you didn't see that? No, I didn't see that. Oh, let me show you this. And all of a sudden I say, wow, hey, that's another way to do it? Yeah. There's another way. I love synthetic. In fact, we're going to use synthetic. Yes?
Well, why is it negative 1/2? Why is it positive 1/2?
It should be negative.
Oh, here in the, gotcha, thank you. Trying to change these markers from blue to red, black, concentration rate. Thank you, thank you. Whew, are those the zeros now? Those 3 zeros. Now, here's another way you could, you just have to be on the alert. To save yourself a little time, on this one, the student gave me a negative 1/2. I tested it by synthetic and it worked. How many answers was I looking for originally? 3. Now we're down to how many? 2. 2 are remaining. 2 tells me there's a quadratic out there somewhere. I'm looking for 2 zeros, but I've got a quadratic involved. Since I know 2 are missing, guess what? There's your quadratic. There's your quadratic. Now, can anyone tell me, with those numbers staring at you, what's the name of the quadratic at that point?
2x squared plus
2.
10.
Oh, I'm hearing it. 2x squared plus what?
10x
Thank you, and
minus 12.
look at that. I could stop up there if I recognize that, set that equal to 0 and solve that either by factoring or whatever, and not, yeah, I had done these other 2. It's up to you. I'm going to finish this up. I could divide by 2, I'll have myself out here, x squared plus 5x subtract 6, I think it is, guys. My goodness, I guess this factors into what, x plus 6 maybe, and x minus 1. We step back and look at it, it does. Split this up, we know what to do from this point. Where I finally end up with these 2 answers with that method. That would save me from additional testing in that synthetic. You just got, there's so many techniques going on here, you just gotta be clever. If it's gonna take you just stacking up to get the answer, go for it. If you see, no, professor, at a certain point I can take those numbers out, write something, and go factor or do something to it, okay? Guys, we're okay here? Okay. Now, here's the original, my goodness, I got carried away here. Where am I? Oh, that's middle
Is
school.
there any,
Go ahead.
is there any real reason to pick negative 1/2? Like it's just,
No, I asked him, I said, what fraction was that number? Negative 1/2, he says, professor, just test it. Right? And that's what sometimes it comes down to. You just test them. I've had some of my students test, look at this, based on my 16 possibilities. Jonathan, they'll start, the first number I listed, they'll test it, then they'll test the second, they'll test the third. Some will jump around among those 16 and just randomly select one from the 16. Can you imagine the exam or the quiz when you see one of these? All of a sudden, we have 16 possibilities to look at, and all of a sudden, Aiden may be having good luck that day, like I will. I'm hoping for in Vegas this weekend, but I'm hoping Aiden will start checking, and he finds one of these answers quickly. He was so lucky. He just went through the 16. Says, Professor, 3 looks cute. I'm gonna test 3. And all of a sudden, you see him going out the door. He's done. He's finished. he's already found all the other zeros. Then all of a sudden Johnson's sitting there until 8 o'clock that night. I said, Johnson, you hadn't found one to work yet? The rest I'm still looking through. And all of a sudden he says, I've already tested 15 of the 16. I said, good Lord. Professor, can you give me just a few more seconds to test the last one? I've already tested 15. And for some reason, either I made a mistake or something, they didn't work. Jonathan, go ahead and test number 16. Go ahead, I'll give you a few more seconds. And all of a sudden it works. It works. Where's Aiden? He's home. He lucked out and found one to work out fairly quickly. So are there some ways that I'm going to show you next week that may cut down on these? Yes. There are some methods that will cut down on the number of possibilities. So you will not be here all evening, 16 possibilities staring at you, and you test them one by one by one by one until you get it to work out. And all of a sudden, Aiden said, I'm not going straight through with one like that. I'm going to just jump in and try one way down here. And he looks out and it works. I saw a hand going up. What was that? Yes?
I don't get where you got the 2x for the following equation with before.
Let me try to find where you are, what you're asking for. Oh, this right here?
Yes.
This is the original function.
No, it's below that.
Oh, below it. Oh, I got this.
Yeah.
Okay, on this one, I said you could have stopped right here, taken these numbers, use them to write a quadratic. Put the 2 here, 10 here, negative 12 there. And then you solve that without additional synthetic substitution. Okay? Oops. Okay. Gotta stop here soon. Now, before I leave it, here we go. Can anyone be clever and tell me? Here's the original. Can someone tell me now? Oh, this is what I like. Anyone now tell me, based on what you see here, I have my 3 zeros listed, negative 1/2, 1, negative 6. Anyone now tell me what that original function, look at this, looks like factored. Now, before you start thinking about it, if I ask you to factor this, you say, Professor, no problem. Professor, I love this class. I just love this class. There it is factored. Now I'm asking, what, this? Yes, look like that. Now I know you're a little tired. If I get a response on this, yes.
Quantity x plus 1/2.
Okay, she's a professor, I'm thinking something, I'll give you a negative 1/2, she wants me right now to say this, and I'm gonna put it down as she tells me. Okay, tell me more.
Quantity x minus 1.
Love it,
Quantity x plus 6.
love it. Love it, love it, love it, love it. Now, one little issue. It's one little issue. You always got issues, we got issues. If I ask you to multiply all this together, expand it out, actually take time to expand this out, multiply it together, what would the first term look like?
1.
No, the first term,
1x cubed.
1x cubed. We wanted what though? We wanted 2x cubed. Didn't we? For the first term, we wanted 2x cubed. I love what she's giving me. Now I think she's going to change it for me. Right now, what she's giving me is correct. It just so happens it's not in bid form because if I ask you to expand it out, you would end up with 1x cubed for your first term. I want 2x cubed.
The
Go for it.
forgot the a, which is 2. 2 quantity.
You know what also you could do? I heard you perfectly. Look at this. Could you rewrite this as that? But that still gives you the negative 1/2 we had earlier. Now, I guarantee the 2 will show up if I expand the thing out. Beautiful. There it is in factor form. Wow. Miriam, I can see why we have questions about this. and it's tedious, people get aggravated. And we haven't seen all of it yet. This is just a glance at what's coming up, okay? Now, yes,
I guess it just like doesn't work like a confession about the middle school thing. It's like I actually just do it that way.
with like the middle school kid did?
But I like instead of it like just looking at the 5, I do 6 times -5, and then I do that.
Oh, now that, yeah, but he wasn't doing it, I
No,
got
he
you.
was just missing the first
It's
coefficient.
just messing with that constant, his focus was on that constant.
Okay,
Lord.
that's okay. Yeah.
Yeah, no, I understand, with the leading coefficient and the constant,
Right.
that makes more sense.
And then
No,
divide
he
by.
didn't look at the leading coefficient, he was just looking at the constant, yeah, okay? Mary, since you've been asking, tell the class, could you read for me, please, from that handout, is there a section called rational zeros theorem? Now, hang on just one second. Math is not the easiest to read. I guarantee you, as I sit in the airport, waiting for a flight, and I see people around me, I love to just sit in the airports and see all these different people. And they're all sitting there. Everybody has a phone, me included, I have a phone, you're checking things out. I guarantee you, they are not reading, maybe somewhere, maybe, I just almost think no one's reading math or looking at math on their phone, waiting for their flight to wherever. Some may. Some may. Some may be just nerds like me and they're looking at math. No, I think they're looking at something else. So it's not the easiest thing to read. So when she reads this, whoa, listen carefully. Here, and go for it.
Okay. The rational zeros theorem is let p of x be a polynomial function.
Okay, stop there, because, we're gonna break this down. So I gave you a polynomial function. Up here I had 4 terms, so we know what they look like. Go for it.
So it says as given in part 1,
Okay.
where each coefficient is an integer.
Okay, hang on. So each one of these coefficients must be an integer, no fractions, none of the original, no decimals, no pi. Okay, go for it.
If p divided by q.
Whoa. Okay, so they call it P over Q. Okay.
In lowest terms, it's a rational zero of p of x.
Okay.
Then p must be a factor of a, 0.
Subscript 0, which is what they're going to identify as a constant term. I'll do all this for you later on. And
And, q must be a factor of a subscript n.
that's my leading coefficient. Is that what we were sort of doing here when we started testing or not, or when I asked you guys for possibilities, or no, to come up with the possibilities? Is that what we were sort of doing to get the possibilities to begin with? We listed all the factors of the constant term on top, and all the factors of the leading coefficient on the bottom. I think it's the same process. Then you put all this together, they call it rational zeros theorem. Aiden, when I hear the word rational, what do you think of? When you hear the word rational?
Any number that's not in the square root.
And no square roots involved,
Yeah, no square roots.
okay? Any eyes?
No.
No? And do we actually, when you hear the word rational, do you sort of also hear or see the word ratio in the word rational? So that's what they're doing, they're doing a fraction, P, and they call it P over Q. That's a ratio, rational. Michael, with all that said, and we'll do more with it next week, a lot more with it next week. We're saying, this rational zeros theorem, and I have my 3 answers staring at me somewhere up here. Here they are. You have no square roots ever up there coming from the rational zeros theorem. because square roots are not considered rational numbers. You'll never have an I up there coming from the rational zeros theorem. There'll only be these that could be expressed as ratios, like this, like that, those types. Now, Jonathan, we know at this point, we could get a square root to come out for an answer somewhere. We've had square roots come out for answers in here, haven't we? Have you guys had also I's to come out? Imaginaries? This theorem will not give you those. This will give you only what they call rational. So you said, Professor, suppose there's some I's in one of these coming up, some imaginaries. And there will be. You know, I can deal with those and see how those also come out. And list those.
In that polynomial that you gave us, would you be like, what would that mean? What would-
Okay, well, which part?
The, 2x cubed plus 11x squared, so like, the a of sub O would be -6.
Oh, got you,
and
exactly, the A subscript 0 was 86, right? And A sub n was 2.
And what does that mean? What's
That means the
-6
constant
over
over the leading coefficient. The factors of the constant over the factors of the leading coefficient, which is exactly what I did here somewhere, but I didn't erase it. I listed all the factors, there you go. They call it A subscript 0, and I'll tell you more about this next week. That's your constant term, all the factors. They call this the A subscript n, I'll do that next week, leading coefficient. Right now, I want you to start getting a sense of, it comes down to testing some numbers. Find one to work, hopefully, and then from there, try to find the other remaining ones. That's what I want. Okay? Woo, Amir, was that all they said about rational zeros theorem?
There were.
There's some examples though, yeah, there's some
Yeah.
examples there. Okay, okay, now hang on, cause I got some extra credit for you guys. Geez. I was gonna have something like this for you guys to attempt at least, for a little extra credit. Tell me what the first one, I may have done the first one, I've already done the first one from the handout. We got the 0. Tell me what the next one is, we may not finish it up completely today, cause I need more time, next week. Tell me what the next one looks like.
The next one is P of x
Okay.
equals x to the fifth
Oh, hold on. Okay.
minus 7x to the fourth
Oh, no.
plus 19x to the third
Wow.
minus 37x squared
Okay.
plus 60x
Hang on. Plus 60x?
minus 36.
Minus 36.
Yeah.
Oh, I think you now are getting a sense of why I must, on Monday, come in and give you more little methods to get the answers. How many answers am I expecting? You gotta get 5. 80?
Yeah.
If I use that P over Q they call it in this rational zeros theorem, Jonathan, you were asking, I can at least do this today before I ask you guys to start your extra credit. I can at least do this. She's telling me the P are the factors of that constant term, I mean, like the middle school kid did. List all the factors of that constant term first, that goes on top. Now, I'm gonna list it like this to save a little time. I know it's 36 and 1. So we'll write plus minus 1, plus minus 36, combine them. That would be one possibility. 2 and 18, another set of possibilities. 9 and 4, another set of possibilities. 12 and 3, I don't think I have 12 and 3 yet. 12 and 3, another set of possibilities. Guys, am I overlooking anything? 9,
No.
4, 12, 13, anything else? Or is that it?
218.
Oh, 2 and 18?
No, we have,
Yeah.
wait, we already have it.
Yeah,
We already have it.
Whoa, whoa, whoa.
It's
Ah,
on, it's.
gee.
Yeah.
There it is. repeat the, numbers there. Anything else?
6 and 6.
6 and 6. Okay. Let's just list it one time. 6 and 6, 6 times 6. Is that it? Or the 36, negative 36? Now on the bottom here, we looked out here, the leading coefficient is what? 1. So the little middle school kid, wherever he is now in life, I hope he's doing well. Maybe Elon Musk, I don't know, maybe I talked to Elon Musk, I don't know. But, maybe he's doing well. His method would work here. If you have, time, you go through and check each one, okay? I'm closing on here shortly, I've got time for your extra credit. Does anyone, before I close it down, when I set this up, guys, look at this. Look at this. Make sure I have all that copied down and not copied down incorrectly. Looks good. Guys, and now I'm stop. Does anyone, I see anyone up, think they know a possibility to test, because you have tons of numbers that could work? Give me your favorite number.
It might be 1.
Might be 1. Here goes. I won't stop. I think we've done enough. Okay, 0, let me just real quick with one marker here. 1, 1, negative 6. Now let me mess up. 13. 13, negative 37, and 13, that's a negative 24. Negative 24, I think that's a 36. 36. And he's out the door, and he's at home. And the rest of us are sitting here mindful, and we haven't found one to work yet. We haven't found one to work. He's home. Relax. Just because one was, the first number, or was it really?
Start from the lowest number, and then it was the lowest.
Oh, he's got a little scheme there, he's going to start with the lowest number and work up. Whatever it takes. But I do have some little methods myself, I'll show you next week to cut down on this. Now guys, get out a clean sheet of paper. I don't have a handout here, just a clean sheet of paper. This is your little extra credit, put your name on it.